Okay. Simplifying polynomials, except these polynomials are much larger. Okay. Now, if you recall from what we talked about last time, operations like positives and negatives, they separate terms. Okay. So if we take a look, there's actually a ton of terms right now. There's 3 terms within the bracket, and then there's 1 term outside the bracket. This term outside the bracket actually has to be distributed to all 3 of the terms in the bracket. Same with the second half of this question. We have a term outside, and we have our plus and minus, so they're separating, so that means we have 1, 2, 3 terms. We're going to have to multiply each of them. They call this in math distributive property.
Yeah.
Sometimes they'll call it like using a rainbow effect or something, but the idea is I do it to this question, to this one, and to this one, and then I do the same thing over here. Okay? So we're going to go through the multiplication process to start. If we take a look here, we have our coefficients and we have variables, okay? So here's where we got to make sure we know the difference between the two. I have a 5 coefficient, I have a 3, a 2. This is technically a constant. There's nothing on that one, okay? And then here we have a 6, and actually I want you to see the entire thing. Think of it as negative 6. Yeah. There's nothing
1
here, which is 1, very good. A 3 and a negative 2.
2.
The other parts that are important here are our variables. So we have to make sure we keep the powers of our variables. Now, there's actually a variable here too. I can show you, and hopefully it'll make them a little more sense. We have x squared.
Is
and
it
x.
because they put the 1 instead of just putting the x?
Yeah, they haven't put a variable technically there. Just like, on this one we don't have a constant, but we assume it's 1. I can make an assumption on my variable. I'll explain that part after. It sometimes is a bit more confusing, so I don't want to go too far into it until we do this thing first. So, what we're going to do is we're going to take what we started with here. Oops. This guy here. And I'm going to multiply by the very first term, okay? So, when I multiply, I have to do coefficients by coefficients and variables by variables. So my coefficient 5 times coefficient 3 is going to give me, yeah. Now here's the trick. Because this is multiplication, I take the variables and I add the exponents. If there's no exponent posted, we assume it's 1. So I go x to the power of
3.
Yeah, 1 plus 2 is 3. And then we've done the very first one, okay? I'm going to highlight this one in blue. Same process.
And then it's 10 x to the power of 2.
Now, there's something really special that we did miss out when I was highlighting a little. Technically, there's a negative there.
Negative 10.
Very good. That's all right. So negative 10 to the power of 2. That's right, because there's technically a 1 there. So those 2 terms are together. I'm going to underline them in blue so we kind of see what our answers were, okay? And then the last one, we do this and 1.
And 5x to... just 5x.
That's right. 1 times anything is just the number itself. There we go. We simplified those 3. Let's move into our second one here. Our second one, we'll start again. What color I start with? Red. With negative 6x squared times 6, or just x squared.
So that's negative 1, so just x to the power of 4.
So recall that there's a 1 here. And remember the first thing we got to do is multiply our coefficients.
Oh, negative.
So negative 6 times 1, what did that give you?
Negative 1.
Close.
Negative 6.
Yeah,
sorry.
you're overthinking it. That's okay. Negative 6, and then what's our exponents in this one?
X to the power of 4.
Very good. We added the 2 powers, so we got x to the power of 4. Let's move on to our second one. So that's the answer to the first relationship, let's say. The second one, we have blue and blue. So we do our coefficients, negative 6 times 3.
It's negative 18.
Yeah. And then our
X to the power of 3.
Very good. And then try that last one while I set this up.
Positive 12.
Very good. Now,
X to the power of 2.
Yes, x to the power of 2. Now, I'm going to talk about this invisible exponent I said here. I could technically write that as x to the power of 0. I could have done it here too. X to the power of 0. There's a little rule. I don't know if you've learned this. Do you know what the value of anything to the power of 0 is?
Anything to the power of 0 is 1.
Yes. So x to the power of 0 is equal to 1. And what would 1 times negative 2 be?
Negative negative 2.
Yeah, so this is why we don't write it in. It doesn't change it.
It's the exact same
It's the
as...
exact same. But remember, if it is x to the 0, remember when we add exponents, x to the power of 2 plus x to the power of 0, well, 2 plus 0 is 2. So it works out fine that way too, okay? So just a little note. Not that we had to do that, but that's great. Okay, so we've got our answer here. We're not done though. We actually have to find like terms. So remember we said the positive, so pluses and minuses or positive and negative signs, they separate our terms. So we actually have 1, 2, 3, 4, 5, 6 terms right now. We got to figure out which ones are like terms.
But wouldn't they all be like...
In order to be a like term, coefficients, they don't mean much. It's all about the variable and the power. So, do I have any other x to the powers of 3s?
Yeah.
Where?
18x to... Negative 18x.
Very good. So I'm going to go back to highlighting again. This and this are a like term. Any other ones?
Negative 10 and...
Okay. Negative 10x squared and...
And positive 12x squared.
That's right. It's all about that. And then the other two?
They're just
different.
by themselves.
Yeah, they're by themselves. We don't do anything to them. So we actually have two sets of like pairs here. I can move them around, or I can just do the operations in my head. It's completely up to us. Oops, that's not what I wanted. Let's try doing the operations ourselves, okay?
So...
Let's start with the x cubed. 15x cubed minus 18x
is
cubed.
negative 3 to the power of 6. No.
You're not sure, right? Because we did multiplying. Remember, multiplying is when we add or subtract exponents. If we're adding or subtracting, does anything change in those exponents?
Oh, no.
No, just the
It
coefficients.
just stays, okay, so it's x to the power of 3.
Very good. Excellent. Good. So you've checked that pair off. Let's look at our other pair. Negative 10 and positive 12. If we combine those two.
It's 2x to the... 2x squared.
Yeah. Is it positive or negative 2?
It's positive.
Great.
2.
So that positive tells me which operation to use, right? So positive 2x squared. And then these ones, nothing changes. So I'm going to write 5x minus 6x to the power of 4.
Does it matter which order these are?
Great question. In terms of simplifying, it does not matter. A lot of times teachers want you to write polynomials in order from the largest exponent to the smallest. And if they want that, then we can do that. That's not a problem. It's a little simpler to look at that way, but in terms of operations, it doesn't actually matter.
So wouldn't it be this first?
Yeah. So how would I say that number?
It would be 6 x to the power of 4.
I want you to look very carefully.
Or negative 6x
there
to
you
the
go.
power of 4.
It's negative 6x to the power of 4. That one's checked off. What's the next largest?
Negative 3x to the power of... Negative 3x cubed.
Yeah, very good. You can say to the power of 3 or cubed. That's completely up to you.
And
what's
then
next?
positive 2x squared.
Yep, very good.
And then positive 5, just x.
X. We could write to the power of 1. It's just extra writing that we don't have to do. Checked off. You've got it in the right order. So we multiplied and we simplified by adding. We did both. We did the last question and we added a new thing in it. Okay?
So